Day 146, Physics Circuit Homework, problem number 2A. We need to solve this system, simplify it, and then determine the current and voltage and power of each of these three resistors. So the first task is to draw the simplified diagrams, figuring out where to start. In this problem, we will start with the 2 and the 1 ohm resistors that are in series. Together they will make 3 ohms. We'll redraw that diagram. And there's the new diagram. 2 plus 1 is 3. And now we have a 6 and a 3 ohm resistor in parallel. So we'll combine those by taking 1 over their total equals 1 over 3 plus 1 over 6. If you do the math, our total here comes out to be 2 ohms. So the final diagram, in this case, we have basically a 12-volt battery with a 2 ohm resistor as the replacement for all 3 of the original resistors. That's a different resistor than the original 2 ohm resistor, but it's an equivalent resistance of the entire circuit. Then we will apply Ohm's law to this final circuit. That is V equals IR. Since V is 12, R is 2, we have a circuit current of 6 amps. Okay. We really didn't need to do that in this problem, but I did it. 6 amps. Now, going back to this middle diagram, what we know is true is that these two resistors are in parallel. They have the same voltage. They do not have the same current. In fact, the 3 ohm resistor will have twice as much current as a 6 ohm resistor. But they're both directly connected to the battery, so each of them is 12 volts here. So I can apply Ohm's law to each of them individually. I'll use green. So for the 6 ohm resistor, I'll do V6 for the 6 ohm resistor equals I times R for the 6 ohm resistor. Well, it's still 12 volts. We're looking for the current. Its resistance is 6. So the current in that resistor is 2 amps. And likewise, for the 3 ohm resistor, we have V3 equals the current and the resistance for that resistor. It's still 12 volts as well. It's the same as the 6 ohm resistor. They're both connected directly to the battery. I times 3. So the current there is 4 amps. And this all should make some sense because what's happening is there's a 6 amp current from this spot to this spot as the battery pushes it. And we saw that in this final diagram here at the bottom. The battery is pushing 6 amps of current. That 6 amps of current gets to this spot right here and it splits. So we just found out that 4 amps goes around through the 3 ohm resistor at the top. So we have 3 amps going here. And we have 2 amps going here. So that's 3 amps. I guess I'm using a highlighter now instead of a solid pencil, but I'm sorry. That's the 4 amps at the top. 4 amps, and then 2 amps through that middle branch there, because 4 plus 2 is 6 amps, and double the current goes through the smaller resistance. We can even go to the top diagram, and once again, so this here is the 6 amps with 2 amps going this way, and the 4 amps going through those two resistors. Each one is getting a flow of 4 amps. That current comes back together in this spot right here and then becomes 6 amps again. We can answer most of the questions so far. The only thing we don't know is at the very top, what is the voltage of each of those top resistors? For example, the 1 ohm resistor at the very top. So I'm going to apply Ohm's law. V1 equals I times R for that 1 ohm resistor. We know it's got 4 amps flowing through it. It's a resistance of 1 ohm. So for that 1 ohm resistor, it's a 4 volt 4 volt potential difference, 4 volts for its voltage. And oh man, excuse me. And then for the 2 ohm resistor at the very, very top there, V2 equals I times R for that resistor. So the voltage for that resistor, it's got 4 amps of current flowing through it. It's a 2 ohm resistor, so V2 equals 8 volts. I can fill in the entire chart now, but you can double check some things. Those last two quantities that I just calculated, the 8 and the 4, adds up to 12 volts, which it needs to do. It's got to be a 12 volt total voltage. I can fill in the chart now, or let you fill it in. Bottom line, all the circles there go in the appropriate spots in the table. I'll let you do that. And then once you have the currents and the voltages plugged in, then you multiply current times voltage to get the power, the last column. Make sure you include units. The power will be in watts. The currents are all in amps. And we'll move on to the next problem.